Topic: smart grid technologies for energy efficiency and active demand side management. Pleasant good afternoon to all. Now the topic will be the security and privacy issues in smart grid, cipher physical system approaches. So for this, we have our beloved chief guest, that is Dr. Sofna Rekha. She is presently working as an assistant professor senior grade in School of Electronics Engineering at VIT Chennai. She is keen researcher working on multidisciplinary projects. She completed her BTech Triple E from VIT Vellore. Presently, it is known as VIT University Vellore in the year 2003. She completed her master's at Shastra University in the year of 2006. She also completed her PhD in the area of smart grid approaches with embedded design and computational intelligence at VIT Vellore as a full-time research associate in the year of 2016. She has been working in the blend of industry, research, and academic experience of 11 years overall. Presently working as a cipher physical module design workflow, worked on various projects in the regard to smart grid, computational intelligence, data learning approaches in smart grid, cloud computing arena. She has been acting as an associate editor of IEEE Access Journal from 2018 and also been a reviewer of various SCI index journals in IEEE transactions on the topics related to smart grid, renewable, sustainable energy reviews, and also IEEE transaction on industrial informatics, to the name a few. So published various journals in the area of domain with high impact factor journals and so on. She has delivered several key talks in various conferences and workshops, and she also been a scientific committee member of the various conferences in India and abroad. So we are privileged to have her as chief guest for today's event. We welcome you, ma'am, and we hand over the session to ma'am to continue the afternoon session. Thank you.
Sir, thank you. Thank you, Mr. Vinod Kumar. Can I start the session? Yeah. Yeah,
sure, ma'am. You can present it and you can start, ma'am.
Yeah, sir. I'm not able to share my screen. That's why I'm looking. Yeah, you're able to see my screen? Hello? Okay. It's my voice is audible, sir? Yeah? Hello? Yeah, I'll switch on the video so that better. Okay. Good evening. Good afternoon, everyone who are present over here. And I think mostly will be students will be working in the electrical background. So I'm here to explain you about the important understanding about smart grid. So you people have been knowing about, see, if you are a normal BTech student, the area of understanding in the smart grid area has a long approaches. So I'm a person who are working completely on a cyber physical system approach. So cyber physical, because being an electrical engineer, I was an electrical engineer, moving on to my arena I had applications of embedded and smart grid in there. I'm working with few professors abroad in Halberg University, and we got few projects also. We are working on completely on a cyber physical aspect. So I'm trying to deliver a lecture. I'll try to explain you. My presentation will go depending upon, I'll make you to understand where is the problem, what is smart grid. You people should be knowing about smart grid, where is the problem happening, and how as a researchers or the students, when you're doing your final year projects or concentrating on you moving on, suppose you're getting into a company, so where is the focus required when you wanted to be a cyber physical system, cyber physical approach. That's what I wanted to give this topic, because this is a very good topic. It's required for a budding engineers to understand. For example, where we can talk about AI, you can talk about data mining, you can talk about cryptography, you can talk about 5G communications, everything put into smart grid. We are only localized, or you are only focused only on the legacy grid, only on the smart grid part of the electrical component. But we are moving into the next spectacular next waveform. What happens is you should understand how this grid is moving on to the cyber part, cyber component. So that's what my complete focus could be. So I'm going to concentrate on these particular areas. As they have given an introduction about me, I'm not going to speak much about me. This is how my agenda could be. So I'm my few of my slides in the beginning will give you what is, because if you are a layman who doesn't know anything about the smart grid, you'll understand what's happening in smart grid and why I choose a particular important topic on this. So why we are going into it, and I'm going to give few understanding about what the work we and few of the professors abroad had worked on it, and the results part, what we have done. I cannot show the entire results part, but what we have done. So because if you are a student, you can do your projects on this or thinking on this area, because when you work on this, you will have more focus to get into a different kind of, you wanted to do an MS and all this. This has more focus, and I'm as in a VIT also, most of my students who are working under me, they work on the cyber, because I work with electronics and computer students who completely work on the cyber physical approach on the electrical. So I need a student of computer science background also to get into it, to understanding. That's how the world has to look into the electrical engineers. That's how I'm going to give you a light through it. Hope my session could help you to know a little bit about where is the privacy concerns. So this is my state of art. I'm going to tell what is a smart grid, and I'm going to picturize you completely a grid in a form of a cyber physical system approach. So I want you to listen what I speak, because I speak a lot, and then I've given only examples and diagrams, and most of the slides which I've picked up is from my own papers which I have done. I have made because it's a very new area, the security part. So I've given the understanding about that. And then how the importance of security is there. So what is the importance of security? Why I have to give more concentration on security part? And what are the different model approaches? Until now, there are few model only has come into picture. That means everything is materialized only in a theoretical approach. So how we have to make it in a practical approach? So when I wanted to bring data mining or machine learning, the AI or the security part, attacks, DDoS attacks, all to this particular electrical background, you should be knowing around what kind of model approaches you want to do. So when I want to, suppose you are an MTech student, you wanted to focus on the research part of it, where is your problem statement could lie, and what is the focus could be, key mitigations. So that is only my focus could be. So my various model approaches will be my paperwork which we have done. I could have shown you, or I will have shown as a results. Maybe I'm not running the MATLAB code because of few reasons, but I would give you the results, what's happening, and I'll explain you the results also. This is how the plan of action. So to give a small understanding, hope you're hearing me, right? Yes? Fine. Hello? Hello? Okay, thank you. So the first, this is all, see, generally, we will talk about only we are learned about what is a grid, what do you call my old legacy grid, why I tell it is a smart grid. Now it is a bonanza, or it's become a magical hyper word, smart grid. Whoever is doing research put in this word called smart grid. Now I would say that smart grid materializing in India would take a long time, or it may take, or it may not. But abroad, many countries are focusing on the grid as smart grid, because which requires lot of questions. You have even questions are only line. There is no solutions. So how we are going to do it? Before that, I wanted to tell you What is a smart grid? As I said that, your normal legacy grid, that means the old, whatever I have, the whole tradition grid, you could have studied in your electrical engineering, the basic power system, the transmission, your distribution, everything. So how, that means you have a power station, and from the power station can be anything. So which kind of energy you want from your power plants, you generated your transmission, your distribution side. There, the problem is, in that case, in the beginning of the legacy grid, it is only one way. I don't have bidirectional. I don't communicate back. Always a particular area or a particular work gets better only when you have bidirectional. And the problems also will be more when you have a bidirectional, and solutions also will be better. So who is the bidirectional person? So from the transparency, always we have legacy meters at home, old meters at home. Most of them we have energy tech. In India follows a standard fixed tariff scheme. We don't have dynamic pricing scheme. So dynamic pricing scheme is like, if you look at foreign countries like Europe and all that, they have the concept of dynamic pricing scheme. That means depending upon the loads you practice at home, or the amount of load you use. Suppose you're a working man, or you are using your electricity completely, power completely. You have to, depending upon the appliances you work, you want, now smart meters are come into picture, where Siemens, GE, most of the companies, ABB, and all these companies produce smart meters. In India, only I could say in Bangalore, in Mysore, one of the area, they have kept these smart meters, and in Pondicherry and in few areas they kept the smart meters and they're practicing it. But full-fledged nothing is worked on. So where is the problem lies? The problem lies between communication. Who is the communication? The communication between the consumers. We are the consumers. Again, when I say the consumers, when I say suddenly to a particular person, a normal layman person, you don't want to have a fixed normal legacy meter. I'm going to have a smart meter fixed at your home, and you should have smart appliances at your home. See, in India is a growing country. When you look at the economy part of it, you will have explaining a normal person about all these outstages problem. It will lead into a lot of issues. So for this, what are the main consideration? So simply is like, as you have a phone, as you have everything, you put on the word called smart. It doesn't mean you are making it smart. I would not say it is smart neither. You are giving some good information or an intelligent information you're passing on to it, and making the equipment much more learnable. So that is in the form of an electricity. The most difficult kind of a system is the electricity, the power sector, because you are interacting with a different kind of generation, that is the power station, to the consumers. The consumers, again, you speak consumers, you are in different sectors. I'm a residential consumer. You can have a commercial consumer. The diagram shows you have a commercial consumers and industry consumers. So again, three areas. If you look at a country like Europe has successfully implemented smart grid and smart meters fixation at home. So when you look at this, they have a policy there. For example, when I wanted to fix smart meters for an industrial sector, so for example, I take a refinery or any other unit, or suppose for your understanding, I say a milk factory. You can easily communicate with the policy of that particular country. It's very easy because the demographic condition, I say demographic means you are easily to find out the route. Suppose in India, you don't even have places where electricity is there. You go to north, so deep east and all that, you don't have electricity. You don't have proper routes. Connectivity is not there. Even they don't. So in that place, when fixing, and in India, you have 4 grids, the northern, eastern grid, southern grid and all that. Communicating everything into one sector and separating them to 3 different consumers becomes a Herculean task. And then the majority is a residential consumers. And again, if you say residential consumers, we are different kind of consumers. And if you go to Europe, you can segregate if you look at the policy wise, if you find out the consumers, you can easily find out who are in this sector, who are they call as white collar and all the jobs and all, you can find out. But India, we cannot find out these kinds of consumers. That can be a house without any smart appliances, a normal house, an average. One house can have luxurious or smart appliances. Everywhere you have fixed tariff scheme. Again, the residential consumers. Again, a person, how many person living at home, how are you looking at the appliances, scheduling of appliance, there comes into a picture. That means what is your understanding here? There is a communication between the consumers, that means we are the users, and who is generating, and I all put the word generating. You have a utility center in between. The utility center is a center. Technology wise, you move the center, call it as, there's a diagram called data center. Data center is nothing but a center where it takes in all the information about the consumers. Now in India, you have Tangitco or different kind of Bestcom and all that. They are taking care of the complete data on the particular localized area. When you think you remove all the legacy meters, because it's very easy to maintain now, because I don't have any dynamic. You're not going to check anything. For a particular slab, for example, you have got 2-phase connection, 3-phase connection. Depending upon that, your bill rate will be there. You are above this, a fixed tariff is very easy. There is no part of interaction between consumer at all. But when you fix a smart meter, suppose I have an AC, I have a fridge, I have so many fans, everything. You are at home. You can easily, when I switch on a particular fan, automatically the smart meter depicts you. So this is the load which is given to you. So this is the tariff. So like that, every meter, every appliances is linked with it. So, and you again have 3 important concepts in everywhere. You have peak load. When you have peak load, when you have offload. For example, in any country for that matter, you have peak load. For example, evening 6 o'clock, you have peak loads, where all many commercial consumers can work. Morning time, it's off peak load. And afternoon, 12 o'clock, again, you can have a peak load there. So suppose if I wanted to reduce your bill subsequently, I will plan all my heavy loads. Again, for example, I can use my washing machine early 5 o'clock in the morning. You can plan your scheduling appliance. It's again a big research area where I wanted to schedule my appliances. Again, what are the loads? What kind of loads you have? Schedulable, non-schedulable loads in residential consumers. Again, so you can bifurcate all this. So why I speak all this? Because it's very easy to speak. Implementation part, it lies in security, a very, very important center. For example, I have one house, consider it's my house, it's your house, you have a lot of appliances at home. Consider you're a working woman. You're moving out on a daily basis. You have planned your scheduling. That means I have planned my scheduling appliances. So I have to use my washing machine in the early morning is off peak load. I use suppose it is a summer, again come criteria of summer and winter season. And if you're abroad, you have again the seasons, spring and all that. Again, in India, I can separate as only a summer and winter. So where I will use my heavy load, AC, how long I use it, all that comes into picture. It depends upon every single person. Look at the problem of data, the huge data. So for example, one single person, one day, if it is a summertime, he will play with the appliances like this. All the data is collected inside a smart meter to get this information. So if it is above the rate, you will have dynamic. Suppose next day he is traveling somewhere outside, it's completely appliances are all off. So second day, day 2, it's all 0 because it's stricter. You don't have, suppose maybe the basic, also it will not take the basic. Suppose in India, if you are there or not, the fixed pricing scheme will take you the basic amount of billing. Finally, we are targeted only billing scheme. As a consumer, I only concentrate on billing, nothing more. So that's how I'm going to win. So why I want you to tell this, because this is the major area, the smart grid or the major concentrating area. Everything, I understand everything is more, but where is the risk is more? Only on the consumer's part. So because we don't even give one data. Normally, if you ask someone to give some particular data, it becomes you have to have an authorization. I don't even give my data like that. Your per day data, every time it is going inside with a legalized, authorized number. For example, this house, suppose I live in Chennai, a particular house, a particular number, you'll be numberized, it goes into a data center. I'm imagining myself, I have a smart grid. So I have a data center, every data is coming inside on a per day basis, every minute is calculated. So you can now, if you look at abroad, in Europe, in German, they have 50 minutes database depending upon the government policy, that policy government. But India, again, you can't give policies like that, because we give a policy, there is always a person to give. You cannot make any policies like that. So that's why energy market comes a very important area here. Or we have to frame the markets there. So when I give the data, how secure the data head. So you have only one smart meter. Suppose I have an apartment, I have so many smart meters fixed to it. How much is the data? It's the big data. So that there comes intelligence inside it, heavy number of data. Again, you have all you have, because the connection of data is only because of wireless connection. You're capturing, you're storing the data. The security issues is daunting there. So thus one house was having so many connection means, think of all this data getting into one particular center. It is easily you can have privacy concern. So this only perspective only I call it as a cyber physical system. Cyber physical system is nothing but as you have an interaction between the cyber and the physical world. Now I understand the physical world is nothing but you're generating, you're transmitting the data you give. And the component of your cyber is nothing. Where it lies between the data you get into it. So obviously, your cyber component, when I implement smart grid, the work is easy. That means I do smart. Why I do smart grid? Why do I implement? Simple thing on the user's part. You don't look at the utility part. Of the user part, I want the bill to be reduced. That is the only thing. And if I reduce the bill, even for the few of the governments used to give incentives. If your monthly bills have been reduced, after 3 months, you like a loan, like it's been reduced. So you make a plan there. So for example, as you have energy theft. There can be easy kind of theft because data is simply traveling. You can put another IP address, get into the data in your smart meter. How we are going to look at this implementation? People talk about smart grid in India, and it's been 10 years or more than that they speak about. There comes the problem of a cyber physical system approach on the security part. That is only the lacking part. They have created smart meters. What is the next step? So as I said that, this is the element of smart grid. I split into 4 areas. One is the electrical network part, which I spoke now, demand for electricity, consumers and supply of electricity. These are the 4 strong areas where the research is going on and still going on. Last 10 years it's going on, it's still going on. But after doing all this, we come and stick where even I'm stuck or people are working on the security part. Where is my security? Because we say 5G, I wanted to travel my data, I speak about till 6G. Then 6G communication come into picture of data. I'm collecting all the data, it becomes a big data. I do data mining into it. You tell, I suppose I wanted to make a smart planning of my scheduling of appliances. I can use artificial intelligence. Like for example, some people must have studied about this scan of supervised learning, unsupervised learning methods and different ML techniques, which speaks about deep neural network. Because when I use a deep neural network in smart grid, I've also used in one of my publications about deep neural network. So when we use that, we completely use the data. So for me, data collection was a huge understanding of how to collect it. Data is enormous. How you want to play with data? So first part is a normal one. So again, this is very limited. Now I bring into the devices, again, the household. Suppose I bring an electrical vehicle there into it. Again, battery management comes into picture there. Then suppose you have solar. Again, solar, your renewable energy come into picture. Distributed generation will come into picture. Because why I bring solar in order to handle my load. I wanted to handle my load properly. I had to have a proper peak shaving part. So these are the 4 strong areas. Electrical network, which is generally happening. Digital information control technology. Dynamic grid. I use the word called dynamic grid because it's flexible because of the building. And resource optimization. I tell resource optimization why. I say resource optimization because I wanted to use solar and all that I wanted to do. Smart technologies. What kind of technologies I want. I bring into embedded design into it. So we have hardware and software co-design. It's so much you can do in this area because it's the strongest area. The second part, demand side management. What all I spoke 5 minutes back. How I'm going to manage the demand response. How I'm going to handle the smart appliances. How we're going to rely on the data. So next one is consumers. How the consumers are going to manage the information. What is your smart appliances? You can't get smart appliances like that. So what kind of appliances you have standardized? And next one, supply of electricity. How am I going to understand the peak shaving? How is my load? You have to fix into it. That comes into strong area. Electrical network, demand for electricity, consumers, and supply for electricity. These are the 4. If you understand these 4 strong areas, research is still going, still it will go, even 10 years, unless you implement on the smart, because government says we want smart city. Smart city, one of the strongest area, one of the powerful, if we are implementing fully smart grid, it's half of the job is done. It is a smart city because electrical network, directly speaks enormous understanding. So when you wanted to focus on research on certain area, these are the area, and now these are the areas being worked with. Above that, there is one person sitting there. How secure is my data when I travel to a common database? There comes a question mark. How you're going to give a security stand? How it's possible when I use a normal authorization data? Suppose I send a data, just an OTP or any kind of a message is enough to handle your data. Anyone can track it. So that's the concentration. So this is a few diagram which I've taken from few of my papers. When you look at the first diagram, so the 3 diagrams, if you look at the first diagram, is a simple diagram. Where is the security part lies? So when you look at the first picture here, it shows about power generation, power transmission grid, power distribution grid, and power consumption. Example, power generation. So when I said about the renewable part, so where, suppose example, non-renewable wind energy, solar energy, the first part. This is the general power system architecture, which we are studying these days. So means when you look at the last diagram, you have power consumption. So we have an interaction between the transmission, distribution, generation. There is a middleman, a smart meter, and the major person on the customer part, and the microgrid. Microgrid is taking care of a small area in that particular region. So I have a localized, a part of a this point, but our concentration is fully towards the smart meter. Now, the next diagram shows me the data of coming into site, how I'm going to bring the communication part. Communication part is nothing but I'm transmitting. Look at this, there are small smart meters in my diagram. They're all connection, each house smart meter. They're all communicating inside everyone. So that means that you call it as an NAN, neighbor area network. So each one is communicated in a particular localized area. You have a common from the smart meter, data is gone. You have an IP address which is being created. Where is the data getting into it? You have a base. For example, if the normal data is very easy, someone reads the data, they find out the data. It's very easy to understand. Nowadays, your data is generating on a minute basis or 15 minutes gap. You are localizing it accordingly. So when it moves on to a larger area, suppose one set locality, for example, I am in Chennai, for example, I say Chennai particular area, Ashok Nagar, and some other area I say. So they're all been fixed with smart meters, means area 1, area 2. They're all getting into one particular base station. So that for the particular North Chennai, I have a data aggregator. Data aggregator is nothing but I collect the data completely and fix it out depending upon the timely basis. For example, I do it in the morning or evening, I fix the data there. And after connecting it to it, I go for a major control center. Control center means the complete. It can be however you want. When I wanted to do my research, I can concentrate it as only on a particular set of people. Not suppose when I speak in India, I have one control center. So many, you imagine the data, a small area, you have a wide area networks. Like that, you will have so many wide area networks coming into picture. So for example, I say Chennai, I say Hyderabad, I say Bangalore. I have so many wide area network, which is connecting to a control center there, which is having a wired backhaul. Now it becomes a wireless backhaul network there. So that becomes, look at the structure there. The network is bigger. And then when I move into the home area network, that means when I look at another localized area, HAN is nothing but the network which is being created among your home, the smart devices. For example, I have an apartment. I have 2 houses, one smart metering data has been connected. And you have to have a home area network. For example, I kept one more diagram called build area network. That means I use it in an apartment. And build area network, a complete apartment, I have a customer side network. And the next picture will be an industrial area network. Suppose I concentrate only on the industry. So again, in that case, I have an electrical vehicle at home. I wanted to give my data. I want to store the data or the supply or the load which I have gone and give back to my infrastructure, critical infrastructure. So vehicle to grid network. So look at the diagram. It has so many networks. It's orally, they're all data which is coming into it. How we are going to handle this data. The second diagram is also a HAN network. So look at the first diagram here. It's like it's a diagram where I have a fridge, I have a a vacuum cleaner, a washing machine, and I have a solar panel, and I have a diagram of an electrical. Maybe it doesn't look like an EV, a car. I consider this as an electrical. So all becomes an HE. So first of all, when you're concentrating on research, on the privacy part, you should concentrate what kind of network you wanted to create. Whether you wanted to want band data, building area network, whether you're concentrating of HAN. HAN is only the data which is available in a single home, and neighborhood area, NAN. So if you look at your research papers, or when you look into a lot of ABB white papers and all, they'll be concentrating on all these networks part. So next one is a wide area network, which is concentrating on all your NANs and home area network together. So these are the networks you have to concentrate. The third diagram, which shows again a smart, for example, it's a picture of some smart grid operator. It's an European one. So they have a central server, which is talking about every data. So local aggregator, you have this picture shows aggregator here. Aggregator is nothing but a particular area, whereas I have one wide area, WA1. So one, for example, Chennai North, WA1, Chennai South, WA2. They will have a local aggregator. Now, what happens is, the data comes into this local aggregator. From there, so many local aggregators are there, 1, 2, 3, 4. From there, again, the data is transmitting to a central. How many paths it has to follow? It has to follow from the home area, NAN, wide area network, and the central server. So data is moving like fast. And plus, where we have is, you will feel confused. Where should I put the security part? Where will have theft? I'm not talking about the normal energy theft. Where will have your wireless or your data theft? I put as a word called data theft. Where will my data gets leaked? Becomes a question mark. So we should concentrate on the solution. This diagram shows where you can fix. Can I fix it for everywhere? The data. Whether my data aggregator is central aggregator is separate for industrial consumers. If you look at the industrial consumers data, it's completely less. It's at least manageable. Even the research works are concentrating only on the residential consumers. They have not concentrated on industrial consumers because getting data from one industry concern, they don't give data there. For example, when I talk about industry, the loads, so for example, I take a refinery unit, you will something have, you can, for example, they have a plan of 24 hours, plan of action. Suppose they have a particular unit, they'll be using the unit only in the morning time, evening time. It goes like that. So they can split the data. So there becomes how you're going to handle this. So this diagram depicts you all this. So my next slide is a little bit more there in points. So when I look at this, where all I should concentrate, it becomes my question. Now I understood that from this picture, the data which is coming in, I have so many data which is fixed in. Where I wanted to concentrate is my next question. Where I have to concentrate completely on the generation transmission parts, and or I have to concentrate only on the smart meter part, what I have to do. So generally, this slide shows you when I wanted to create an efficient energy market, I should concentrate. The final benefit should be this. But the background, what do I say? The background hall is this much. So many confusions, so many data. But in front of you, this is all is required from the government, or it is required from a better energy market. For example, the first one is a power availability and quality. Means you should have fewer blackouts. For example, once in Bombay, there was a blackout way down back, and you require a self-healing system. That means that's why we move into smart grid. So I want to, if I have a problem, it has to heal by itself. For example, the power has been damaged. You are going to manage the power by yourself. You have to create. You don't require a common elements to take care of that. That is the quality. That's how the quality comes in. The second important line, cyber. The most of the research presently they are concentrating only on the security part, the cyber physical approach. So they speak about AI. So what is this diagram and the sentence completely holds together. I should continuously monitor my data. Continuously monitoring of data coming in different form. Moment it is coming out from your smart meter, it becomes a local data. There, how you're going to play the data there. So why I should be it becomes a cyber world there. So you have to monitor the system. It's very difficult to handle this part, the security or the continuous monitoring part. The next part, it becomes the efficiency. Now something you have heard about the brownout, blackout and the brownout. The brownout is nothing but Suppose a particular area has been left, it has been there, there'll be a blackout consideration which completely halt the particular area there. So that has become the brownout situation there. So that when you have the situation there, how are you going to manage these kind of problem? Energy efficiency. And last comes, which we speak from so many years, environmental and conservation benefits. So mentioning all this, the main task person is a smart meter. So nowadays, smart meter is actually, if you look at the market, day by day or every 6 months, as we have we have mobile phones coming into pictures. Smart metering, initially when I started research way down on 2000, very not late behind, so it was smart metering, only one company produced smart metering. Then later there were so many companies delivering smart meters. So depending upon it can be, so this also, the development also comes into picture. So the earlier was a meter rating, then the AMR, and the second generation truly smart meters. So truly, when I say truly smart meters, the data should be completely continuously monitoring, and it should have a proper communication between the central server. That is the AMI, Advanced Metering Infrastructure. Are we truly a smart meter? And how is your fixation of smart meter depends upon from an industrial consumer to the residential comes into picture. They're all the types of meter sophistication has to be carried out. This is how the clear picture in front of us. This is what requires on the smart grid part. But these 4 words of power reliability, safety, I'm concentrating only in the safety and cybersecurity benefits. The energy part, each one is an own research area by itself. Next one, user roles in security, privacy concerns in the smart. So I would split my talk into 3 different areas. The first one is like where all the problems can arise. So I said so for example, why I chose this diagram is because you can look at the concept in terms of, so I put you in front of you in the cyber world. So you can take about, so nowadays people work on a lot of AI technologies and all that. For example, I don't know how many people work on machine learning. I do work on ML. So for example, something called as the reinforcement learning is there. You are talking about the deep neural network. So when you look at the reinforcing element, you have an agent. That means the process has been learned by the particular network by itself. And the agent will say whether it is right or wrong, whether to move on. So can I bring in data mining into it? There is another big area. So this is the problem in front of us. When you look at the utilities, from the utility part, data leakage from the central server, consumer trust, regulatory. So everywhere you have policies. He can leak the data anytime he wanted to do. Data modifications. That cannot power billing and grid operations. And next one, platform sharing, pricing, and forecast algorithms. So consider, I'm talking in terms of only the future smart grid. So when I have how much dynamic is your data, how much dynamic is your pricing? It's similar to your loan only. It's like how is your interest rate has been changing. Similarly, you understand how floating is your pricing scheme, how long it is, whether my pricing scheme is common for throughout the years or whether it is only for a particular, or it is from individual. German country, what happened? It becomes individual. I have individual pricing scheme for an individual set of people. If I make my data clear, and if I'm able to reduce my bill for a particular, you get incentive there. It becomes incentive, and it becomes flexible for individual person. So that comes the part there. In consumers pass, again I said that residential, industrial, commercial. Everywhere the problem is data leakage again. Behavioral monitoring, industrial SPNOC. So when I look at the word SPNOC is nothing but how the industrial consumer, the SPNOC is nothing but how are you going to continuously monitoring the industrial part. Again, as I said, the word data, very, very, very strong part, strong area to be focused. If you are an young generation student, if you get back and look into a lot of elsewhere or transaction papers, or you can read a lot of white patterns from ABB. So suppose, because even I have seen many of my students who've been moved on to compute from electrical to the, maybe I'm working in electronics. I've seen many people working on the data science part on the smart grid area. They have become business analysts, data analysts in many of smart grid companies. So why? Because the data, power usage, power measurement data. The last one is called as the data third-party. Who are the third-party service providers? So, for example, in India, you have Reliance, Tata, and all. They become third-party service providers for the Indian government to take care of the data. They become, so you give the path, give the authorization. So when these people come into smart grid again, data, the common data which is being governed becomes smart metering. How are the data? All these very good companies get into picture. How are you going to handle? You have to handle them also. So these are the use cases in front of us. So after this, after a few slides, I would say what we have done in our work. That's what I focused on. So this is because if you look at in a lot of papers, they would have given you only theoretical background, and still the work which you have done is also again theoretical only, but kind of computational analysis we have done. So this is one user as sold where you can set back your concentration. So one data leakage or data modification working on that becomes a strong area. So what are the issues? Because I'm focusing my topic a little bit on the future also. Because how is your business problem could be. So when you are a secure smart grid security issues and opportunities. So when I look at this, when I bring the communications, you create new risks. So when I change into when I communications get betterized, what happens there? You create more risks there. And it becomes, when I create a problem there, it gives an opportunity to give a better thing. And the second important thing, how we are going to protect the critical. This is power system as a critical infrastructure. It is not like even healthcare is a critical. If I look at the, as I said, the cyber physical system is an interaction between the cyber and the physical world. For example, when you look at the cyber physical system, you have health, you have agriculture, you have energy sector. One of the critical, even healthcare is a critical infrastructure, but one of the strongest, but the data localization can be handled there. But here you can't handle data because it becomes public. It over to organization, it moves it. And the cybercrime becomes a cybercrime playing with the data. We don't know. You have a lot of proxy data which is coming into picture. You give it separate IP. You have to do so many things. It becomes, you give a chance of more of cybercrime there because when you require more sophistication. And obviously, the incident becomes a catastrophic situation, a haphazard situation, when you have playing with so many IP address data coming into pictures. So how I'm looking this at as an opportunity. So when I'm looking at the opportunities, I will identify, as I said in an earlier slide, when you look at the earlier slide, they're all areas. So when you look at the next diagram, where are the opportunities lies? The opportunity is like how I'm going to look at these. So I put it as IDIR. Identify, develop, implement, and reduce. So identify the security and privacy vulnerabilities through actionable risk-based approach. You can do this only by an approach. Approach can be different cases. It can be residential consumers. Again, you split into summer, winter. Again, you become community changes. It becomes changing it. So you have to identify your problem and localized on the data. The second thing you develop, if you look at the power sector, you have to create for a residential consumer, the security. So as we have some standardization. So for example, I use a particular protocol, communication protocol and all that. So we have to have a policy for it. And technical architecture and guidelines you should create. After that, you should implement the scalable properties and check at every single point. Endpoint starts from utility and the user and the third party side. After that, you have to detect doing this, still you will have problem. Computational problem exists into picture. You want the data has to move very fast. The data should not be having any theft there. It should communicate fast with it. It's all matter of second. You should address the potential threats which is happening. This is the opportunity which lies in front of us in a large scale. These are all, the earlier which I told you, the blue boxes are nothing but business problems. And these are the opportunities, which again brings all the cyber component into it. If you are a student, I would strongly tell you, focus on all these areas where you can become a great analyst on working on the data. So this all plays an identification problem. And look into your projects, you can work as one of your projects, looking into the any kind of help I would also give you. So how the vulnerabilities you can carry on. So again, when you look at this, you have to understand the diagram which I showed earlier has an interlink here. So I showed utilities, consumers, and third-party providers. When you look at this diagram, what it shows is that our security and privacy are the same. I'm for so long time, I'm telling you security, privacy. You're like, what is this security? What is this privacy? Are they both same? Are you going to handle it both together? How secure is the data? How private is data? Privacy is something you are taking care of your own data. When it's with you, it's private. When I get the data open, you are giving into the common network. You will think about how is your private data becomes secured with you. So if I have all my data in my phone, which I'm not passing into my cloud and all that, it means this data is private with me. I'm not going to moving on to this. I'm not getting into the second. But when you get into the center, so I would not say they are both same. They are a connected word in terms of in time of critical infrastructure and smart grid. So these are the very, very strong. The both, what do you say? They're all, I say interlinked. They're all interlinked here. So when you look at the understanding, I have two diagrams with two shades here. I made a small diagram. So what was it? It's like customers. We are the customers. So customers can be anyone. And the customers can use whatever you want. I can use, if I'm a residential, even if it is, I can use AV, I can use EVI, for example, industrial, I can use renewable, on all this comes. And then in between, you have utility, you have your transmission, you have to manage all these people. And third-party entities, third-party until regulatory services. So when I'm looking at these are the critical infrastructure. So I'm telling you, privacy is your data. Security, when you open the data, it becomes, you opening into the world, it becomes critical infrastructure. So that's the understanding between security and privacy. So when your data, how? So in the data itself, the account transactions is nothing but the data among yourself, the data of your appliance. If I have 10 appliances, I use something called in data, I'm not getting into too much of technical, when you get to it, it's something called deferrable, non-deferrable loads in scheduling of devices. So we get into and read all this, but you can just say which are the deferrable loads and non-deferrable loads, how you can schedule the deferrable load, how you can schedule the non-deferrable. So demand response is nothing but, so again, the data which is, the load which is, are you managing the load? It is enough for you to handle this. Again, DR policies come into picture. Complaints data, marketing data comes into the picture in the industry consumer. It becomes privacy, your own data. And I move into my critical infrastructure where everything comes into picture. It becomes common now. Security lies. There comes internet service and wireless network. It looks, so it uses telecommunications compliances, not just energy providers. Now I use the word, it becomes wireless now. That's why if you go on and put in smart grid, nowadays people work on 5G, AI, 6G on the smart grid. Even I have published a paper in one of the highest impact factor, renewable and sustainable energy issues with a foreign professor on IoT and smart grid. When I look at that, when we worked on the paper, it was completely on the industrial IoT design on the end. We worked less on the electrical part, but more on learning new IoT design on. So it is, we should move on to a more perspective on the cyber world, because we are handling only data. I don't say the background of transmission, we require it, but we have to know a little bit about that because we become bidirectional. So I put this as 3 sentences. One is massive new volumes consumer information are generated day by day, day to day. New critical infrastructures has to be relied upon. Information and energy are bidirectional. So as I said that, they're all one together. They are not completely different. They are binded together. So that's the understanding of security and privacy. So when you're doing research, you can understand the lightweight security and privacy on the privacy becomes lesser to handle. Security becomes tougher to handle. So we have to look into a better algorithm to understand the security part. That's why I gave you the slide, because it is a wrinkling line in everyone's mind about what is the difference between security and privacy in this market. So moving on to the next one, as I said till now, how are you going to put in the challenges here? What are the challenges I can just look at? So that's the understanding. So you till now, we have focused on how it's moving on, how is the structure here. when you look at here, the data characteristics. So as I said, that three important lines you should remember always: utilities, consumers, and the third-party service providers. When I'm looking into it. So when I look at here, now we understand from this itself, there are roles. Now I gave you the challenges in front of us. Identify where you have to identify. You remember the earlier diagram, I had the NAN, I had the HAN, I have the PAN network, I have the wide area network, I have the data aggregator. Where I have to keep the security, where I have to keep the privacy. What do you, privacy means, where I put an authentication, data has been transferred means I put an authentication protocol, a particular allowing certain protocol. I use a cryptographic technique to handle this. What I'm going to do. So next we have to focus on how is the data is pushing into it. So this completes, it becomes data. Now I'm speaking only in the computer's perspective because this is the area where you should focus more, and we are more or less focused on this. Data characteristics and security privacy issues on this part. So first I concentrate on the data part, the privacy part, and then move on to the security. Since I gave you a slash because it's one and the same, but it is imbibed together. That's the understanding. That's why I give you a slash. For example, the first thing is like I've split into 4 words of 5 things. One is called data diversity. I don't know how many people have worked on cloud. Maybe all of you are electrical engineers, basically. Yes. Yeah. Hello.
Yes, ma'am.
Anyone have background on cloud computing, edge, fog? No. Hello. Okay. Anyway, so when you look at now here, okay, fine. I'll throw some light on you because that's very important also nowadays. So now I have not given a slide about that because we had been working on something on data. Now what happens? I'll get back to my diagram, the early diagram. So when this diagram, what happens is I have a home area network, NAN, wide area network, and backhaul network. So what happens here is the data which is coming here, you imagine one home, one smart meter data is there. You are putting on to one smart meter. It is going into a common. That means it's getting into a cloud there and transferring the data. So each one becomes a cloud there. You have a common, everything it is getting into content, it puts on in the cloud. So nowadays you have different concept, and you can go and read on this more. Something on edge computing, fog computing, and the cloud computing. When I entirely concentrate on one control center, the data is getting, it becomes a cloud. When I look at the edge and the fog computing, the lot of computing, cloud computing is in there. When you look at the edge and the fogging computing, edge and fog computing protects the data only on the, when you look on particular network. When you look at the fog computing, and you have different combination, edge, fog, cloud. Cloud protects the entire thing. When you're protecting the entire thing, what happens in the cloud database? There is a possibility of some problem or any security issue. That's why they move on to the fog, and earlier it was only cloud. And it becomes public cloud, private cloud, hybrid cloud. The data becomes open and private becomes only for this particular. So now when you look at this, you can concentrate on the edge and the fog computing. It's nothing but the data we consider only on the particular sector. Then you can concentrate on all this. So when you look at this, what the kind of data you can look into it. So it can be direct and indirect data, distributed sources, diverse ownership, and heterogeneous cloud services. So what is the understanding which I've given? So diversity is nothing but how large, how profound your data is. Diverse, that's the meaning of data diversity. It is not one kind of data. So that means a house can have different kind of data. It can be from appliances, it can be from a set of solar data, it can be from non-renewable energy sources. You have diverse opportunities there. And legalization comes into picture there. And in data, something called heterogeneous and homogeneous cloud storage devices. So when you look at this, a private cloud, I don't know, most of your Amazon web services, you can look into it, Amazon and all these companies, they all work on the heterogeneous cloud storage services. So they have a common IP network to handle all this data. So we have to focus on the cloud computing part on this area where the data becomes there. And the next comes data granularity. Data granularity is nothing but, again, AI, the artificial intelligence part. the data size, the collection rate, security concern on the latencies. When I look at this, if I have a huge data coming into the picture, how I'm going to handle this huge data to the third-party consumers, how secure my data is that. If the data is moving in, if I'm able to understand the data maturity level in the particular case, again is a question mark. The next comes data transmission. Means from the HAN, it is moving on to the NAN and it's going on to the wide area network. Now it becomes going to a central local aggregator there. It is transformed. Now it becomes a multi-owner data aggregation. It means control data means that data is nothing but multi-owner. You have many people, common data is there. So you can, again, there is a huge open opportunity, cloud computing and fog people, the data part. That means the electrical is moved completely towards the cyber understanding because we are handling data there. Integrating and private and public data. So certain data can be private. For example, few of the industry consumers' data can be made private, or so you can public data. How we are going to understand? You have IoT, Internet of Design, to handle industrial IoT, to handle all these data. Comes into picture. That is how the fourth generation requires it. That the focus should be there. And I'm telling you solutions. So for example, the cloud heterogeneous, I can use a fog computing, cloud edge computing to handle all this. Why I say fog computing means it will handle a particular set of data only on the particular. So you're trying to help to secure only the data. When I do a combination of cloud and fog, it will combine this data and give you a better protection of your data. And next area becomes if you are getting into moving on to the economic market, data access and sharing. Where is the repositories created? For example, you have any Apple company, or you have a lot of repositories getting into the data. Where we are moving on to who's sharing the data has been looked. You have to create policies there. Again, you have to create policies there to create shared repositories of data. Now, individual access, whether I am used to handle, whether can I use individual access control there. So whether I can create dynamic policies and latencies there. Whether I have to audit my data on a monthly basis. How secure is there? That is again a particular characteristics or challenges. But again, particulars. For example, when I want multi-owner data direction, I can use AI to handle those data transmission. When I wanted to handle the data diversity, I can move on to the cloud. I will show you in a few of my slides which we have worked. And last becomes data archival. What it means that when I grow the policies, data size is going to only increase day by day. And attack is also going to increase. So do we have proper policies or technology markets to understand this? It becomes a multiple jurisdiction. These are in front of you the characteristics which has been built up, where you can bring in a cyber component into these figures. So this is a picture. So when you look at this is the whatever I spoke. It's one of my. So it's taken it from one of the company's data. So when I'm looking into it, you see the picture shows us enormous understanding. When you have a backhaul, I showed you a diagram called backhaul network. It's like completely the networks in between, which is talking about. When you can split when you look at you can have a direct. We'll start from the customer interaction. When you look at the last side, where I have to fix the smart meter, advanced AMI, advanced metering infrastructure. When I look at this, I have the consumer interaction distributed generation, means the wind solar plugin, distribution generation part, and again the distribution generation and the energy storage. So it can be your VPP, virtual power plant. What kind of you wanted to get into it, you can understand everything. The pump storage, hydro generation, and the consumers and the devices part. So here you have your residential. Again, it becomes home area. It all becomes home area network. Commercial, your malls and all that, industrial data. Now it becomes all individually. It becomes private data. Now we are moving on to the second part. I'm going to interact with utility to take care of my billing. So that becomes in between becomes your meter sensing network. So I'm not getting into more into the communication because we have to need some knowledge about the communication part. Don't worry about the names into it. I'll give you a broad understanding. When you look at the sensing part, you have cellular. That means you have a lot of communication understanding. Again, communication engineer has a lot of scope on developing. What kind of it's about concentration on these areas. The data, what kind of data, how you have 6G, 5G. One of my papers were on 5G communications on smart grid. Which 5G, is a 5G is suitable for the smart grid? Because how quick is the data has to be done. Backhaul network is the networks from different areas coming into picture. How we're going to handle this network, and this part becomes completely your cyber understanding. So it becomes the enterprise service bus, or you have, so where you bring all my cloud computing, everything. You have a SCADA systems, your demand response system. They're like data centers. For example, Google have completely a data center which manages all the data. You're Googling stuff and all that. You have a complete data center. They're all into a cloud. Like that, all this becomes a particular system there, metadata and system. And it becomes a reciprocity there. The aggregation storage happens, becomes a concentration. So it becomes, what is the problem? Because we have real-time data. When you look at this, when you become real-time, it becomes, because the daily data has been transmitting. Real-time, traffic is more. When you have traffic is more, the data getting into picture. If you don't have a common reciprocity where your data is going on a daily basis, you have an IoT, industrial IoT, which is you're moving on to the IoT, getting onto the cloud, all this data, all becomes a pro. It becomes a haphazard situation which we have to handle. And next become a back office of all the data, the third parties. I said to the third parties, the distributors, regulators to handle all this building, consumers. Depending upon this analysis, he will give you a final takeoff of your consumer bill. This is a simple diagram of how you are going to concentrate on your focus on the security part. So you can concentrate working on the HAN part, or you can concentrate on completely on the entire part. You can concentrate on the cloud part of handling data, because how we are going to secure these. I'm just giving you a throw on all this area where the focus could be. So this is the complete understanding of the diagram. Now next picture shows you a smart grid landscape. So when you look at this, there is numbers here, 1, 2, 3, 4, 5, 6. So what is the understanding is, where can the attack comes? Who will give us attack? Where the attack? So as I said that till now, I have told you about third parties, I have told you about consumers, I have told about utility from the HN network and all that. So where could the attack could be? As I said that, I wanted to tell you again, I would say smart grid is a cyber physical system. It's an intelligent electrical delivery system. It is going to act to the demand on a different part. And the complexity of the system creates when you have attacks at different parts. We don't know where will the attack happen, where the crush happens here. You have a common global data. Its data is coming in real time. Where we are going to keep the secure part? How strong should be your security to handle this? So we have to think on possible ways, different possible ways. That's where the research comes into picture. A long forefront of doing this work. So where your potential attack and exploit scenarios. So you should imagine where the scenarios could be. I think I have numbered a few things. When you look at this, number 1 gives denial of service attack. It's called DOS attack. So because it doesn't take a particular attack, called as it completely deny the particular attack. Sudden attack is completely another server getting into a picture. It acts as another replicator of data. That becomes denial of service, DOS attack. For this, you should be very, very if your students, I would say that you can focus on your projects, on cloud computing part, where you can concentrate more on this part because it becomes the future. So next one, if you look at the second one, is called stolen credentials. For example, I take your credentials of your smart metering data. You stole it easily. And that is one. Next one, that all comes from the user side. Malicious code, a random code. You have a database of your data. Someone can take your code and you can throw it in somewhere else. Theft of service, fourth one. Fifth one is targeted phishing attack. You can target people like that. You can target a particular area or target an IP address, target anything, because everything is open now. Even you have a picture now, you put your picture onto the Google, it becomes public. When you type a particular person's name or type, you get information, everything becomes open. How long you can look into it, how can you can take, even for us, it's like, look at the data. Network-based eavesdropping. Eavesdropping again becomes, where will the attack could happen? That is the point. The next one is firmware level exploits. Form-based denial of service. Form-based denial, I'm not getting into more into it, but I want you to look into all this. Form-based denial of service is like, for a particular set of network, when a particular network has been attacked, it's called worm-based. So the complete net chain gets damaged. A particular area gets damaged. So these are the this is like scenarios can happen, but that's how companies and bigger companies working on the cyber part, on the data science part, they're all looking on this area. And as I said, a data theft. You can easily. So for example, I am scheduling the appliances data, depending upon peak load, everything. Continuously, I am reducing my bill on 1 month. So one person scheduling data, scheduling appliances pattern, you can easily get. If you are a good hacker, you can get the data from the smart meter and you can use that, follow that pattern in your this, and you can reduce the bill. Data manipulation can be done depending upon the data you get. Malicious insiders, we don't know where from what is happening data. As I have malicious code, I will have malicious insiders. Unauthorized monitoring. Who is authorizing? Who is checking your data? Who's monitoring you? We don't know who's monitoring. That's how, when you are more towards technology, again, it becomes the negative also. But we have to make it as positive. So that's how the numbers here, maybe I would share the slide later to one of the professors there. You can look at it. When you look at here, the first diagram, I have split it into certain diagrams. One is called third parties, back office, the earlier diagram, the back office network. Like this, I've split it here, back office, meter management, data collection system, wide area network. That means now I will not talk about HAN because from the HAN I move on to wide. I'm opened. Now local meter network, smart meter. So I have numbered here what all the theft is possible. You have to think in that way. So when you look at the smart meter endpoints, that means smart metering from each home. It can be resident. You have the last picture had commercial consumers. So 1, 4, 6, 7, 9, 10, 11. For example, one is denial of service attack can happen. Obviously, theft of service could happen. And next one, network-based eavesdropping can happen. And you can have data theft, sure. Data manipulation is possible. Unauthorized monitoring. Anyone nearby IP address can monitor your bill data. So this is the possible attack. Unauthorized monitoring cannot happen in the wide area network because the data is moved there. You cannot have. So you should focus on where this is the, I would not say this is the landscape. This is all my forefront of understanding or whatever I have understood. I picturized you in this way. There can be much more on it. So smart metering endpoints. And when you move on to the local meter network, it means it's moving on to the network there. These are the possible areas. So only when you look at 1, 6, and 7, denial of service attack, the network-based eavesdropping, and the 7th one is firmware level exploits. When you look at this, it can be both the hardware and the software understanding of the part there can happen. It cannot, obviously, data theft cannot happen there. Data manipulation cannot happen. It can happen only on the consumer's part, maximum. Because it moves on to the wide area network, it becomes wireless there. From there, it becomes the data aggregator, data collection system. So again, you should localize where now. So the small cloud is nothing but the data is moving on to the cloud. That's how I showed there, cloud pictures. So now you move on, and next becomes meter management. That means data. I put the word called data repository, means all the data of the particular, it is moving on to a data repository. You can use for a future use. And you have data centers. Many companies have data centers. We're talking about centers, huge number of data. And then looking back office. Back office is nothing but all possible of networks from everywhere. You can keep a backhaul system there. And finally, the third parties. I put a backslash there because he can also come into picture because it is also going to a regulatory. So this is a complete landscape of where the cyber crime can happen. So when you're focusing on a particular area, you should focus. So I've given you a small insight. This is the possible attack can happen. You can concentrate only on the data theft. You can concentrate only on, for example, I wanted to concentrate on data manipulation. I'll give an example of a research work. So I do a data manipulation. For example, 10 houses are there. I've got all the data of the particular house. I'm manipulating the data. So you can use an AI. Hello. You can use an AI technique easily to handle this kind of data here. So So data management. What I say, I don't know how many people are focused on it. So when you look at this artificial intelligence part, you have different kind of algorithms. For example, you have supervised, unsupervised algorithm. You have different. That means when I look at the supervised understanding is like the data has been supervised by a particular person. So you have different. For example, there is one kind of network called SVM, support vector machine. These are networks which is trying us to help the data. Who can come first? A lot of networks design is there, so where you can concentrate on AI based on data manipulation. When you look at the theft of denial of service attack, you can use a cloud computing services to understand the DOS part. How is the cloud data getting into picture? So the screen gives you a complete understanding where your attack endpoint could be there. How we are going to, it's very difficult to handle everything together, but we can localize it. So then only I would not say any network is secured. Even our data is not secured. You would know anything comes into public or a public website, never it is not going to be secure. It's not like that, because we are all looking on this. So this is the area or the landscape. I've given you a small understanding of where the security scenarios, I've used the word called scenarios, possibility could be there. So with that, you should remember, I've given some few points. I'm making my slide in terms of research focus. So when you look at this, where all the area, there is, I would say 10 mantra. There are 10 points I've given you, where all the vulnerabilities could be. The first one is two-way communication. I think I just have 40. That's, I have, okay. The key threads, I'll go a little fast, I'll go. The key threads are two-way communication and trust. So first thing you have to remember that how is the devices, that means the communication between the utility and the devices, how is the trust is. That is from the low level. And slowly you have to move on smart meter security. What kind of smart metering you are getting? How is the deployment of smart metering is happening? How is the connection of your devices? How is the potential? Your smart metering, for example, you have all your smart devices connected to a particular smart meter. So it becomes an how good is that quality there you have to take it. After that, understanding it's a very strong area. Consumer privacy of data collection using data. Who is collecting data? How is the data has been collected? Where is the data is stored? How it is retended or the data has been moved on, becomes understanding the customer privacy data using smart meters. That's why it is very difficult for the government to go and explain about the energy efficiency using the smart meters, because people will not understand what data, what you're going to retain, what you're going to use. Because it's not much told to the layman people understand. The next becomes smart metering management. I do all this. It becomes finally the meter endpoints on a larger scale. How are we going to threads? They're all threads in front of us. And thread modeling. So when I look at this, I have communications between the endpoint. And again, the frequency of communication technologies I use. People use 5G, 6G. You have to upgrade these modeling techniques every time. We started with PLC communications, which is long back. Whether there's advantages here. Next becomes meter monitoring. Suppose there is an anomaly. You have to create a proper anomaly structure. You should not give an unauthorized access. As you have a mobile, you have a key pattern and all that. You should have an authorized access to it. But how long is your authorization? Suppose you should make your network strong. So suppose if I'm not able, if you get your authorization, you should, how secure is your, suppose you're connecting to your mail data, Gmail, getting all your data. How secure that data path is there? And all finally comes into picture. It's not very easy. As I'm speaking 1 hour or 2 hours and I'm moving on, or hearing the lecture. It's not because the cost of adding, when you become secure and secure, again, you bring lot of technologies coming into picture. The cost of adding security becomes more. In so many technologies, I told you about cloud fog, I talk about data mining, I spoke about AI, you know, because so much endpoints there. So adding securities, you should be in a large, because we have critical data. This is the key threads in front of us. If you are able to focus one area itself, it's a strong research area on this key threads. So a few more key threads are understanding. So finally, when I move into the government, I have to have regulatory requirements and standards. You cannot create things like that. You should have standardized standards for smart meter. Till now, if you look at for few countries, go to the energy, that becomes another big area, energy policy. There's so many 77 pertinent standards of smart grids are available. That means policies have been created. Policies are separated again on a consumer part, and it's happening on the consumer part and onto the utility part also. So that becomes important thing there. So next important thing is like how we are going to use the existing security system to the secure smart grid deployments there. So that is another important focus. So that becomes a transmission part. So here it becomes another important thing I wanted to is like you should know to understand the preventive security to detective security. That means how you should not have any defective meters. For example, why I use this word, because when I have a smart metering, you have then it becomes an IoT part. You have a lot of sensors, you have all those actuators all connecting to it. When the smart metering design itself is wrong and you have an anomaly problem there itself, the complete layer structure goes wrong there. So you have to take care of the hardware part. That's why I say it's a cyber physical system perspective on the physical component also. The physical component here is nothing but the design which you create, the smart metering data, which is the physical component. That is also have to have the focus. These are the. Moving on, I have told you the understanding. This give you a clear picture about where is the focus. Remember this slide because it gives you where it happens, where is the problem, authorizes there. So moving on to the, I'm going to the next few slides would be running around my own contributions. Mitigation strategies. So when you look at this, so where you can stop, mitigation strategies means where you can, from the consumer part, where I can stop where I can make my data secure. I can go, I cannot be exposed so much of data. Where can the vulnerability stop? So I put some key points here. Encryption, layered defenses, R&D investments, real-time. This can be, if you're a student, it'll be too much towards, but you can take the important understanding. Real-time monitoring, shared situational awareness, system of system integration, trusted hardware and software. For example, if I take hardware and trusted hardware and software, so obviously it becomes smart meter there. So the dark blue line where the leading part becomes it. So among this, where all areas you have to focus. If you have a trusted hardware focus, you should focus on the smart metering device security. You no need to, but next you have to have an end-to-end collector. End-to-end collector is nothing but all these meters connected to a particular device. That end-to-end collector, open source system, means it becomes to a wide area network and evolving security standards. You should give consideration for all of it. For example, real-time monitoring. Real-time monitoring, you should take much more care on the head-end collector on the CTOS open system. Encryption has to take care everywhere. That means data security should happen everywhere. So these are the consideration of leading security practice. That means it is happening in few of these smart metering in foreign, in abroad governments. It's happening. But we should look on to much more understanding. So if we focus more on real-time monitoring and trusted hardware software, half of the job has been taken care of. System to system integration. Means every smart, we do not have same smart metering design. It differs unless otherwise government produces smart metering design, common smart meters, the entire people. Otherwise you can have localized. If you have in German and all, they have their own smart metering design depending upon their own. It becomes completely, you can get those things. You just have to fix it at home. It becomes differing also. Just you have to have a connection. You have to localize the network. You have to connect the data, give them the data, gets into the common server, it moves on. So this is the consideration. This is a small picture which gives you how the interaction of now the flow of after telling all this. I am giving you a picture on CPS smart grid integration. Now I can look at my picture as the big picture as CPS, cyber physical systems. I will not call my system as an electrical infrastructure. Now I call it as a cyber physical system because I have so much with the data. So when I look at this diagram, if it's a small diagram, it shows you about interactions. For example, meter 1, meter 2, meter 3 only I've kept it as IE1. It's one from one of my papers, IE1, IME2 and IME3. So when you look at this, what I'm trying to say this, like if you see I have some arrow marks, A, C, D, D, E, is nothing but it's like the understanding of data flow. Which kind of data flow is you have to, now I'm telling you all this, you understood from the early picture, attack can happen like this, attack can happen like this, all this. But after doing this, again going into deep into it, How is the information flow? It's again information. How is the information is flowing? That comes into a picture. So when I'll give you a small understanding. So for example, ACBD. So this is the data is like load. Oh, I have 3 smart meters. One smart meter had EV load. Load is the normal load data and PV. The next one has load when, next one is battery load. So you have to understand the physical system. That means smart metering system data. And you should allow a command to make a setting. It means whenever the next appliance is switching on, you should devise a command over that. Message information has to be passed from one meter to another meter. And physical flow has to be created. So this is simple understanding. So why I gave you this diagram is because you should have the proper interaction between the physical and the cyber world. It's very, very important. So how is the information flow? I have spoken you till now security. But how is the information flowed is very, very important. And you should handle it also very properly in my understanding. Moving on to the next slide. That's why I said information flow. Sorry. So information flows, I'm telling all this in CPS. I wanted to throw some light on. I know I have picturized it as CPS model. How is the information flow should be? What kind of information flow you've been allowed for a proper process? So I'm transferring my HAN data to a common wide area network. It is just flow of information. Information is nothing but data. What kind of information will stop you from, affect you from threats or vulnerabilities or attacks? So that flow model you have to create. That's how the research is going on. What kind of information will allow or protect you from the theft or will protect you from an unsecure situation? So when you look at this, potential information flow models in CPS in energy market will be non-interference, non-inference, or non-detectability. When you look at the non-interference is nothing but it does not flow anything from the high to low. That means what is the understanding is that you don't have anything about something. The data is moving from high to low, high data to low data. It's a common set of data which is being transferred. So it is like only the data is moving. It is not like huge numbers. For example, I speak about the peak load. So when the data in the evening, you consider it as the data is high because the data is more. You don't localize like that. So for example, when I draw a graph from morning 1 o'clock to 24 hours, I take it from 0 to 24 and draw a graph for the load. Suppose I take in house, most of the people at the home after 6 o'clock you switch on your appliances. So it's from 6 to 9 o'clock, it's on. Most of the appliances are on. Because morning you consider all of you are out. So that time what happens? The increase of load happens. But you don't prioritize the data like this. Okay, you don't cut short the data. You consider it as 24 hours. But there is a possibility you can take it as 0 to 12 and 12 to 24 and make the information flow. So next one becomes non-inference. Non-inference is like, it is like level of the observer. That means the observer is nothing but the consumer. So it means that you picturize the inference, but it means you can take it as 24 data or you can split them into 12 data or even you can take it as 1 hour data and transfer it. When you take 1 hour data, the data transferring to the central server becomes much more time consuming or understanding. Non is like next, this is nothing, I'm telling you why this because how is the information flow? See, so much of technicalities are there to take care of your security. So how is your information flow moving on to it? That's the understanding. Next one is non-detectability. So non-detectability is nothing but, as I said that, when I'm doing this, where is the set of low-level components, where is the high-level components? You can split them into high-level. That means peak load, off-peak load, and how you can split the data. So this is the potential information flow models you can create. It becomes independent according to your own house residential data. That comes into. So this is how the information. So if I take care of this properly, if I make the information flow properly, here itself you are trying to make security. So I'm giving you an understanding approach. Here itself you are making the data secure. So if I make the secure data, again, when I make it from the low level to the high level, your data becomes much more secure. These are like approaches which you can create in serious models. So this is one from my paper which we have published in 2002. It's from Renewable and Sustainable Energy. It's about 12.1 impact factor. So which is talked where we spoke about how the IoT design was trying to put into it. So we concentrated about when you look at this diagram, it's taken from my paper, so I just made it. So the wire area network, HAN network, where the data is there, we created a separate MDA+ design, a meter data management system, which is in the cloud, how the data is going. We had some inclusion designs which are getting into it. and millions of devices which has been created. How the data has been done with help of some Albach University professor, we were able to create the data. And when you look at this, you can, so when you start your research, you can start from home area network and you can slowly move on to the NAN network. You a lot of research papers are NAN. And again, one important line I have to say is gateway. Gateway is nothing but nowadays you should have heard about the IoT gateway. That means the gateway of millions of data, sensor data is getting into it. So how secure is that gateway? And becomes industrial IoT come into picture. So these are the area where you have to. So till now I have given you solutions also. I've given you challenges also, solutions also. What can be the, I gave you few solutions. One solution could be the proper information flow security. Can be one of the securities. It's a practical data which we have done. There can be n number of possible solutions can be done. So one of the possible solutions is like, as I said, that robust smart metering, the first and foremost. That's why I say CPS. Cyber physical system is the interaction between the cyber to that of the physical to the cyber world. I look at the cyber physical system, creating a proper control system. Control system is a smart metering design. Robust smart metering. How efficient is a smart metering with privacy constraints? Means every time an appliance is sending a particular data, you have to generate a code for that when I create that itself properly, you will not have problem at the next stage. So there, good companies, or you have to look for the smart metering design with privacy constraints. That is one possible strong solutions, I would say. The next could be utility privacy trade-off design. Utility, considering the third party people, privacy. But proper trade-off design should be there. Trade-off design is a policy has to be created. Next one, privacy invention detection and prevention. As I said that you should prevent the HA in itself, home area network itself. That is the privacy detection and prevention. The next one, data masking and data honor. When you look at the data mining and all that, there is something called data masking and data anonymization. So you transfer a set of data, you're trying to consumably going on. So you can mask your data with certain cryptographic techniques there. It means you would not say this is your data. You mask with some other IP, some other forefront and send it to your data to the cloud, the data masking. And data anonymization means you don't know from the server, only from the central server will understand that is your data. In between, you have a masking and anonymization technique. There are a lot of techniques. This all comes into the computer science part of it. However, I'm still not the computer science, but I have worked. I understood the importance of computing technologies, being an electrical engineer, and I focused more on the embedded and the computer part because the world is towards that. So data masking and data anonymization. Lots. So when you look at the above diagram, shows you that different authentications of level. For example, as we all know, as you are an electrical engineer, you all be knowing the control system and state estimation. So what kind of technologies you can get into it, the smart metering designs. And V2G, vehicle to grid networks, how authorization can be, anonymization can be, physical security, encryption. In customer side networks, as I said that a proper smart metering design, cryptographic mechanisms, anonymization, homographic designs, and all that is the possible solution. If we do all this, it's a big way, it's a long way to go. But if you do all this, when you focus, for example, if you're a professor, when you're focusing on these areas, these are the strongest area which is going to build the next 10 years because you are professionally understanding the cloud part and all. And before I move on to my own, I have few slides. Other potential concerns, as I said that, CPS vulnerability, energy, it can be as I said that it can be energy, healthcare, water shipping, transportation, anything. So any kind of network, generally I give you the slide. When you look at this, this is a control layer. So where the attacks can be. This is one. CPS approach, I'm looking into the CPS approach. So when I look at this, the cyber system is the first part is your physical plant. The physical plant becomes your smart metering design, reliability. You have to create a proper control system there. You should, when I don't have, as I made a small disturbances, you should not make any disturbances there. If I'm able to make that, in that part itself, it will create a more resilience when I move on. So cyber attack is easy, can manage. This is how I look at the security as a cyber physical part, which will rule the next, if I bring smart grid. This is the part people will end up and get confused. So this is the focus should be there when I move on the data. So this is one as an example, one of the simple example where I can use data mining. Data mining process, all the data is getting into it. You have a master controller. You create a policy, and one kind of approach towards the CPS security can be a data mining approach. So this is one kind of work which, so next thing I'm going to show you a small, before I end up, I wanted to show you my own work which we have done. So what we have done is we have something done on a lightweight security and privacy preserving scheme for the smart grid consumer. So as I said that, this is one of the approach. I can show you a few of my data. I have not brought in my match. I got to show you my match still. Maybe if people are interested, can ask me. Maybe I privately can you share my code or help you out helping this. What we have done is, as I said that, I told the word called security and privacy here. So as I said, I included the word called lightweight security here. Lightweight security is talking about I don't go higher into the so now you have to understand the HAN, WA network, the PA network. So I am moving on to the complete HAN to the wide area network. That itself, I'm trying to make a privacy concept. So how I'm going to do is I have split into three understandings. So what is that? The existing all the privacy scheme will have the consumption reports of the aggregation of billing purposes, which is sent periodically. The lightweight security is nothing but it's based on the cluster of all. You consider every house is the same residential area, in the same residential area. They are into a forecasting. You make it as a cluster, each cluster, and each cluster have to have an only particular demand. That means they're all a normal middle class family. You consider this is just I make like this. You can make a different own your own scenarios. We had made an utility center, a utility pathway like that, to where they can adjust their total demand, and they're all middle class people. Where the limit, where so for example, every house has had 4 appliances. For example, they had 4 lights. What do you happen? They have only maximum 1 AC. It's a completely they are into so for example they are in a city called Chennai or is some country or some area where depending upon the localization demographic I create my set of consumers and how I'm going to satisfy their own understanding. So in that I split the topic into communication and commutation overhead. Overhead is nothing but it's talking about the final overhead network of all my data. So here I split my work into 2 topics. One is called communication forehand and the commutation overhead. So how is the communication between the consumers and the power utility? So the system model is like this. So when you look at this, now I look at my big picture as as I said at the beginning, you can split your research work. Getting back to I think you would have remembered the slide which I've told you before, the very beginning of my slide. Which is having the build area network. When you're focusing on research, you can start work. Initially, when I started with the HAN network. I worked on the cloud computing part on an HAN network. Slowly focused on wide area, and now completely concentrating on the BAN customer side. That means I'm talking about the huge data I'm talking about. Sorry. So it is all the band, all the data which is getting into a complete network. And the HAN network, built-in network, this is nothing but there is a transfer information which is giving. This is I take a control center. So how is this from this HAN? I will not go straight away to a wide area. I'm not focusing on completely on the wide. I completely eliminated the wide area network where I will not have one set. Now I split up into different BAN. It is building area network. So why I do is because when I split and work, the security, so when I get completely all the data to one area, what happens is there will be possibility of more vulnerability there. Reciprocity will be more. When I split it, the data has been split and there will have from after this band network, what I've done in my model is band 1, band 2, only when you give. So there is in cloud computing, there is a concept of homographic situations where only when the user gives the authorization to the NAN, for example, the NAN neighbor area network requires a data from today to next week. He should give an authorization. The NAN will not have all the data or the control center will not have. This band only will have all the net data here. Only when you request, but he is given authorization when you request. What happens? When you request the particular guy, then only he will transfer the data. So what happens? Security is much more better here. That's why it's called as lightweight security, which we have done. Like this, you can focus on different. This is given of one kind of approach we have been worked on. you can think about any kind of possible solutions. Since to make it a little more understandable, I told us that becomes the commutation for it. What happens here is like the communication also, the threat towards the communication also becomes lessened. The second important point is the commutation forefront also can be manageable. When I speak about commutation, because your commutation is split, the band is having all your data. Whenever the data, we will have put a small, doesn't becomes a public cloud. You can take off a private cloud between the band and the NAN. It means only these people. So for example, band A1 and NA1 can have a communication. Band 1, 2 and only one-to-one communication. Band A, for example, I understand. For example, I said Northern America, South America. I use it. So you can split this network. So what happens is it is much more private here. And you will have better security patterns. When I do this, the commutation overhead also. So when I'm commuting for all the data, it becomes simple. This was my system model. For this system model, I have split them. What are the requirements I took into it? I consider them as customer-specific privacy, confidentiality, and message integrity and availability. Why I use this? Because customers' privacy can be handled because I am giving my data only to the band. Next thing is like confidently and message integrity is happening. I'm confidently I can send my data and all my availability of data is available in my band. So my localized becomes, now when I'm talking about cloud, it becomes completely one cloud server. Now it becomes, when I talk, if you go and read edge and fog, I think some people can go and read about edge and fog computing today. So when you look at the edge and fog, concentrates only on the particular layer. So what happens? The privacy concern and security concern is manageable here. You can understand. So it becomes, so like this, you can make different approaches to take care of your smart grid. So this was a few of my design goals. There's a little bit of mathematics. Don't worry about the mathematics. This is just, we have designed it. So when you look at this picture, that gives you 3 messages. That means that I've passed over the lines. The arrow mark shows all the messages going forefront, back, front, and all. So when you look at this, you just understand the overall. Maybe later, if you want some information, I would share. I cannot share you the entire restriction. I stopped it. So the HA1 is the first network. That means the home area network. Then when you look at it as a small band gateway, it means the first HA1. It means HA1 is the first one, the first house. So when I consider my house, my data, I'm going to a band gateway, a built-in area network. That gateway only is giving information to my, NAN network there. What happens is all the information is stored here, so that we have to make some computation. Here we used some stochastic modeling. There are a lot of modeling techniques out there, which is, if I put that, I made some mathematical understanding. So xi is equal to g of hn is that. G is nothing but I've used some linear computation models. HN means, if you put x, you can see x1, x2, xn. These are nothing but the appliances. Appliance 1, appliance 2, appliance 3, appliance 4. Plus, I have put a sigma parameter. Sigma parameter is like unavailable loads if you have particularly. It can be stored here. So this is all I have to compute on a daily. So I can compute on an hourly basis. I can compute for 15 minutes. I can compute for, I compute for 1 hour. 1 hour for a 24 hours. I have computed any algorithm you can use. Now this algorithm, I schedule one particular, I'm telling you what we did. After scheduling this pattern, we used one of the reinforcement machine learning algorithm. Which scheduling, so many data is coming, we found out which is the best scheduling pattern. That means why I use best scheduling pattern means, if I use a best scheduling pattern, I will have the best billing. So in that itself, I use the AI technique to understand the best consumer path. And that information is passed on to the particular band network. And now after this, the information is passed. And like this, if you look at the second image, you have different HI, to so many messages. Like this, you send the information. Depending upon the demand, you get a price message. That means I am sending a particular day. This is my data. It will compute on a daily based data from the database. This is your price message. It becomes flexible privacy scheme. So like this, so many data has been collected on a day. Band computes all your data here. And then it finally gets into a final gateway and you have a billing message. So that billing message on a day basis you create. This is only available only in the band. Control center, whenever he wants only, he can take the network. He will go and compute on a daily basis. Even though there has been trafficking there, you can send a particular data on a particular date. So like that, you can transfer the data and your interaction becomes, you will not have trafficking also. This is one kind of design code which we created, just published as one of the very standard journals. So like this, you can concentrate on your own focus. This is on the computation part. So I split it in this way because my data was secure now. And this is the performance evolution which we got. When you look at this, I do not show much here. This is my final slide. So when you look at this, I have 4 diagrams. When you look at this, the 4 diagram shows that I told you in the beginning, the works had 2 models. One is called communication and commutation. So when you look at this, I speak about the communication forehead and the commutation forehead. I have, so like this, if you look at the second message, case 1, case 2, case 3, case 4, case 5, what are these cases? So I have, in my x-axis, I have different hands, means home area networks. For example, different, I have 100 homes, 0 to 20. Now, you can split the home network however you want. 0 to 10 is one HAN. 10 to 20 is another. You can split your group of data however you want. And messages, so when you group more, sending a set of messages when you send, it will be easy. Case 1, case 2, case 3, as I remember, I showed you the information flow security. A proper information security, I passed the message. So in different cases, we understood that which was showing us the better. If you look at that, the first case, the left, did not show us better results because the commutation time was more at the time. So we standardized with a normal traditional. Normal traditional means any kind of data which did not have any much of security. We use that as a traditional because how many messages you passed it means when I send the messages more to the cloud, continuously if we send messages, what happened? It becomes trafficking there. And how strong is your data? So how the information packages was done, we made a understanding. And the second graph here shows that communication overhead. Communication is packages, data packets. So when I use that, we created a communication and came into conclusion that this network showed us a better communication type using the network. So like this, you can create n number of, I would not say this one of the, since it is recently published, I thought I will share it to you. So there can lot kind of design approaches can be done for my particular. Okay, then I am done for the day. If you have any questions, you can ask me. Okay, sir. So on smart grid, I said, so the privacy part itself is a major focus where you can, as I said that, which the paper which we had showed there, you can concentrate on one of the strongest areas like you can consider the privacy concern using AI techniques, artificial intelligence techniques, where the scheduling of appliances, you can do it properly. You can schedule, use one of the AI technique, a lot of techniques are there. That is one focus. And then how secure is the data? You can use cloud and fog computing. These are the present area. If you look at a lot of researchers are focusing on the cloud and the fog computing part, you can concentrate. These are the strong and upheld areas. Data analytics part, if you handle itself, it could be better, I would say. These are the focuses which you can. Still researches are going on, paperworks are going on. That would be a strong work because earlier smart metering design was all done. Now security part becomes, and one more important area is communication. What strong communication you wanted to understand. 6G communication. Being an electrical engineer, it becomes a bigger area for us. But when you look into it, being a background, we will understand what is the communication part, where is the wide area network can be. These are the focus areas. So we can concentrate on the cloud, we can concentrate on the ML techniques, a lot of ML techniques. One example, I would say that scheduling of appliances. So I wanted to have an incentive pricing scheme. You can understand, you can use one kind of algorithm to use it and you can schedule the appliances. There are a lot of papers, Science Direct, different algorithms. So researchers can, and the focus is also when you publish on this paper, give more authorization on these work. That's what I would share. Okay. 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 you wanted to focus on the smart metering design, or after smart metering design? I do not understand. If you wanted to consider on the smart metering design, one thing on, if you are an electrical engineer, you can devise a proper smart metering. As I said that no, a proper smart metering design where a lot of companies are working in. How the sensor data, you can develop one kind of smart metering design, which is helping to, where is it, where you secure data, where you can think of a device of security part is there. So that is the where, that's all. But I'm obviously I would say that you should concentrate more on the data part of it. Then is only it's our duty now to look into the data part of it. That's how I feel. If you have any doubts, you can also mail me any work or something. You can obviously, this is my mail ID. You can look into it. And
yeah, good evening, ma'am. This is Maris from Selvam and Trichy.
okay, sir.
Like, do you think that demand side management is a prerequisite for the implementation of smart grid, or we can
Demand side.
go?
Yes, knowledge of demand response is very much important for policy making, right? DR is very, very important.
Yeah.
Demand response policies, because demand response is nothing but or the demand response or demand side management is talking about the demand and the user side. So we have to make a proper DR policy technique to understand the process. So obviously, demand side is also because the major person nowadays has become consumers only, right? So there you should have to create a proper policy making. It's very much efficient. The focus is nowadays what happened is the DR policies. It's been people have worked. If you look at the research part, so much people have worked on the DR part and all that. Now from the DR part, how efficient pricing schemes can be created? What kind of incentive pricing schemes? Because we have electrical vehicle, we have other kind of energy sources which you can, how you can balance with that. All that is very important. So you have to focus.
Okay, I felt like in the start of the session you were emphasizing that the major roadblock is not availability of the smart devices in the homes of Indian homes. Am I right, ma'am?
Yeah, sure.
And then if you are having this some rooftop solar, like some source of energy to pump into the grid,
okay.
Is it not sufficient to just start with the smart grid? Like,
is it not no, sir. Demand response is very much important to handle all these devices. We are looking on to the focus of next 20-30 years, right? So that should be our focus. That's how the pattern is. We create policies.
So until we are ready for smart appliances, we feel like we cannot go ahead.
That's
with the
why
smart
India, as initially I have told, no, sir, demographic situations in India, depending upon the economy level, creating smart devices, knowledge to all the users becomes a very question mark. Where in foreign countries it's been implemented because it is much more approachable there. And now they're looking on the security part of it. So when I'm working with foreign universities with few professors for the paper, they have all the data getting from them was much more better. But your collection of data, everything becomes a question mark. So people are working on the smart grid part will know the understanding of data collection. So that's how I meant to say, depending upon the development of the particular countries, smart grid and demand response plays a huge role, sir.
Okay, ma'am. I have one more question. How do you see the blockchain technology as from your security perspective, ma'am? Whether it will be helpful, or how do you see from your perspective?
Blockchain. Blockchain in what, sir?
Yeah.
You mean blockchain
technology
in the smart grid part you're talking about?
Yeah.
So blockchain part you can use it. See, nowadays blockchain, I have not worked more on blockchain where I cannot throw much light about it. So you can also use it on the I have not worked on the blockchain part actually, where I cannot give you any insight about it. You have to see I can give you an answer is like, sir, is like the area where you wanted to use the blockchain approaches can be used. Where the focus, I showed you certain areas of splitting out different data privacy to the three party, where you can handle this application of blockchain in the smart grid. You can obviously we can fix it. All your computing technologies can be fixed into the smart grid. Many people are not focusing on this particular area, so that's what I wanted to majorly throw light on.
Okay, thank you so much.
Yeah, no problems.
So, thank you.
No problem, sir. You can ask any question. Okay. 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 Yes. Sir, sir, data. Sir, so Indian scenario data set, which I had been worked on my research and I'm also working on. So what we have done is we had made only scenarios, sir. Data, we were predicting the data. So if you go to foreign European repository, all you can easily collect all this data. Depending upon the data, we had made replications of those data, and only we have done using certain ML techniques, where you can generate data. To understand where we can create all this data using some coding, you can where you can generate the data for a particular set of appliances in smart metering. So that's how we created millions of data. So getting for the Indian skin, that's why you can see one of the papers could have been stated completely from Indian scenario. So that's little actually difficult, but you can use some scenarios from the foreign based thing and you can create your own. That's how I have been worked. Long way, sir. A long way, not still way. Long way to get into all those data. Even though it's not very easy to get all the data also. If people are working on the real-time monitoring, we take data only from the foreign universities or the foreign repositories where you can data, or we use data science understanding to replicate the data. For example, if you work on healthcare system, you can easily get an ECG data or any kind of data from, because it's real-time monitoring is easy. That's why it's little difficult over here and becomes a question mark also to focus on this particular area, where you put the word real-time. Yeah, 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 sure. No problem. Thanks for the opportunity, sir. Thank you for the opportunity. Hope it was beneficial, I guess, my presentation was. Thank you. Thanks a lot, and thanks for everyone for the session. Okay, thank you, sir.